Hello and welcome to the third part of the course on temperature measurement using sensors. In this session, we will discuss about temperature measuring devices. We have five basic types of temperature measuring devices. Mechanical devices, which are bimetallic strips, thermo-junctive, which are thermocouples, thermo-resistive, which is RTD and thermistors, radiative type, pyrometry, and non-contact method, which is thermography. In this session, we will be learning about the first three types. Now, what is bimetallic temperature measurement devices? Bimetallic devices work on the difference in the rate of thermal expansion between different metal strips. Strips of two metals are bonded together. When heated, one side will expand more than the other. The resulting bending is translated into temperature reading by mechanical linkage to a pointer. Let us consider an example of a bimetallic strip made of brass and steel. Brass has higher thermal coefficient as compared to steel. So when heated, brass expands more than steel. When cooled, brass contracts more than steel. Let us consider bimetallic strip in a thermostat. A thermostat is like a switch to put on and off an electric circuit. The outer temperature dial enables to set the temperature at which the thermostat switches on and off. Initially, when a room heater is switched on, the bimetallic strip carries electricity through the circuit and the heater blows out hot air. After some time, when the strip gets hot, one of the metal expands more than the other, so the whole strip bends slightly. It bends so much that it breaks open the circuit, the heater is switched off and room starts to cool. As the room cools, the strip also cools and bends back to its original shape. This action will switch on the heater again. Then we will study about thermo-junctive and we can talk about thermocouples here. Thermocouple consists of two strips or wires made of different metals and joined at one end. The changes in the temperature at the hot junction induce a change in EMF between the other ends. As temperature goes up, this output EMF of the thermocouple rises non-linearly. These are the application areas of thermocouple: plastic injection molding machine, food processing equipment, semiconductor processing, heat treatment, medical equipment, packaging equipment, etc. The next is thermo-resistive. In this, we will talk about a resistance temperature detector. In short, we call it RTD. The underlying principle of RTD is that for a defined range, electrical resistance of a metal changes linearly with changes in temperature, which means as the temperature rises, the temperature also rises. Therefore, RTD has a positive temperature coefficient. Resistance also depends on the length of the wire and its cross-section area. The relation shows more the length of the wire, higher will be its resistance, and thicker the wire, lower will be its resistance. Next is thermo-resistive, in which we will talk about thermistor. The underlying principle of thermistor is that for a defined range, electrical resistance of a semiconductor changes linearly with changes in temperature, which means as the temperature rises, the resistance decreases. Therefore, thermistor can have a positive temperature coefficient or a negative temperature coefficient. So negative temperature coefficient means as temperature rises, resistance decreases, and this relation is non-linear in nature. Also, thermistor has larger sensitivity than RTD. In the next part of this course, we will learn about non-contact method of temperature measurement, which is pyrometry. Till then, if you have any doubts, you can mail me at the given mail ID. Thank you and happy learning.